The speed of information processing partially depends on the number of neurons involved in the task. A complex voluntary behavior, such as identifying and reaching for an apple, involves multiple brain systems, sensory, cognitive, and motor, and many neural connections. The elapsed time between recognizing the object and initiating a behavior is thus relatively long. While complex voluntary behaviors are certainly adaptive, there are situations, such as the rapid withdrawal from dangerous stimuli, that require immediate action. A rapid response is one of the advantages of the reflex arc, which involves only a few neurons. In a simple reflex, the entire signaling sequence, detection, processing, and response, is handled by the spinal cord, without the need for input from higher brain regions. Indeed, conscious perception occurs after the reflexive withdrawal has already begun. Let's examine the reflex arc in more detail. First, specialized sensory neurons in the skin detect the painful stimulus and relay this information to neurons in the spinal cord. The information is carried all the way from the skin to the spinal cord by a single sensory neuron, without any intervening synaptic connections. The sensory fibers enter the spinal cord and synapse upon interneurons within the spinal cord gray matter. These interneurons, in turn, synapse upon the motor neurons that control the skeletal muscles. In this case, the flexor muscles in the front of the arm are instructed to contract, while the extensor muscles in the back of the arm relax. By exciting some motor neurons and inhibiting others, the interneurons serve the important function of controlling muscle pairs to generate movement. In this case, the motor neurons that control the flexor muscles are excited, while the motor neurons that control the extensor muscles are inhibited.